and alone. I feel the rain crashing down all around this empty town. I'm searching for the lost and found, but you don't care. Like the sky.
Ready to say yes to the largest online code competition organized by our friends at Shopee? After a strong inaugural run in 2020, Shopee is back with their second installment of Shopee Code League in 2021, happening from the 6th till the 28th of March. To all students, undergraduates, and working professionals across the region, it's time to put your coding skills to the test and compete in a series of challenges. Just form a team of 2 to 4 members and solve real-world problems that cover data analytics, data science, and algorithmic challenges specifically designed by the Shopee tech teams. In addition, sign up for Shopee's training workshops to level up your tech skills. Mark your calendars and join us for the coding event of the year. Just visit careers.shopee.com/coding. Follow PWA Pilipinas social media accounts for more info and other cool stuff just like this.
Cause those hands and lights can't stop me. I'll just hold on for dear life. Yeah, I can't give up this feeling that I get when looking down from the sky. Now
And I'm Andresito de Guzman, your host, along with with Michael Land. Say hi, Michael.
Hello, everyone. Thank you so much for welcoming.
Great. So I guess let's begin. But first, we're going to introduce our organization first. Okay, so we are PWA Pilipinas. Yeah, if you do have questions, please visit bit.ly/fuguask. Okay, great. Next is okay. So PWA Pilipinas is the community organization for progressive web app enthusiasts, designers, and developers here in the Philippines. Our mission is to introduce and nurture progressive web apps development and adoption in the Philippines and beyond by fostering a community for subject matter experts, enthusiasts, adopters, and developers of the platform, and by providing resources and engagement to stimulate interest in the technology. Because our vision is that for the Philippines to have a better user experience because of progressive web apps. Yeah, we do have an app. We do have a progressive web app. Visit app.pwpilipinas.org for events and other things about our organization. We do have that. And we do have Facebook, Twitter, and LinkedIn. Just do search for us there, or you may send us an email. Okay, first, a quick introduction about progressive web apps. So what are PWAs? They're your traditional web apps but added with native apps functionality. There are your PWAs. Basically, your PWAs are web apps with progressive enhancements, and they do have some of these features like being able to work offline, being installable, being engaging, and typically they're smaller than most native apps and shareable through URLs because they're web apps. Okay, so some examples here in the Philippines that I'm proud to share to you. We do have the official Department of Tourism travel app that you can check out. That's app.philippines.travel. We also have one from 7-Eleven Philippines, Click Grocery. Just visit clickgrocery.com for that. Also, we have Starbucks Rewards, so it's also a progressive web apps if you want to check that out. And we also have our own, so PWA Pilipinas app. We do have PWA that you can check out if you want to experience progressive web apps for yourselves. So, yeah, here's our calendar for December. Okay, so I am. We are very pleased to actually have here today our speaker. So I'll be introducing him to you. Where's that? Okay, kind of lost it. So our speaker is Kenneth Christensen. He is a Danish software engineer and architect specializing in mobile and web technology. He's working at Intel out of Copenhagen. He helps define Intel's strategy and plans regarding the web platform as well as put it in action. And before joining Intel, Kenneth was employed by Nokia, where he worked on the Nokia N9 web browser, Qt, Qt, WebKit, as well as many other mobile projects. And he's also an elected member of the W3C Technical Architect Group, currently working on making progressive web apps more capable as part of Project Fugu. So let's welcome on stage Kenneth Christensen. So,
Hi, and good afternoon, and thanks for joining me today. So I guess we should just get started and learn more about like where the web is heading.
Sure.
So let's share my slides. Let's just go full screen, and you can tell me when you can see it.
Yes, we can
It's just
see
loading a bit. So yeah, let's get started. It's a bit early morning for me, so I'm drinking a bit of coffee while presenting. I hope that's totally okay for you. So first of all, like my name is Kenneth, and I'm going to present you today. So I work at a company called Intel. It's a semiconductor. So you might be wondering, like, why is a semiconductor working on the web? Well, the web is basically everywhere today. So you probably know about Chrome and Edge browsers, JavaScript, and the like. So as Andre mentioned, like I'm actually in the W3C Technical Architecture Group, overseeing the future of the web and making sure that all these efforts going on are kind of aligned, so that we end up with a good result for developers and users. So why does Intel care about the web? Well, our friends at Microsoft has been saying that more than 60% of time spent on like Windows on a PC is actually inside the web browser. And it's actually more than that, because a lot of those usages for like what people consider native app, like using something like Spotify, using say like Visual Studio Code, and other apps are actually built using web technology as well, using something called Electron. And the reason why people is using Electron is because sometimes they need a bit more features than what the web can provide today. So it's really important for us to keep on expanding the web so that you don't need to use something like Electron. You can just use a progressive web app. So that is one of the things that we want to talk about today. So the web is really great, or I believe the web is really great because it has this great reach. Like you can run the web basically everywhere. Like my apps on my TV, smart TV, are also based on web technology. You have web browsers on most devices. And there's a very little friction because everything just starts with a URL. But what is also great about the web is that it's safe. Like you can visit a lot of different websites without being like afraid of it, like installing viruses on your PC. It's also ephemeral. So if you visit all these websites, you'll probably not visit them all again. So it's not like installing an app and suddenly you're out of storage, because if you don't visit the website like frequently, like the resource from that website will just get removed over time. There's a lot of other advantages, like it's linkable, so you can link straight into a specific experience. Like say I found a tweet about this talk today, I can send that over like instant messaging to my mom. She can click on it and see that tweet immediately. She doesn't have to install an app. Or maybe even if she were to install an app, maybe then just the app will pop up and she will have to find that tweet herself. So there's all kinds of great things about the web. It's also composable. So you can take a new site and actually embed web content there from a different site, like a tweet. For instance, if you're talking about politics, it's nice to see what certain politicians have been tweeting. It's also indexable, so you have like search engines like Google, Bing, etc. But as I said, the web starts by the URL. Everything is just URL away. And like this is, you're working about progressive web apps, but I normally say that if you've been to any conference in the last couple of years, you've certainly heard about progressive web apps. So these experiences that can work offline or with intermittent network connectivity, that can be performant. Of course, you can write a progressive web app that's not performant, and like also responsive. So if you click on things, you don't have to wait seconds for it to respond. So the web platform is a pretty nice place to be. As I said, there's worldwide reach. It works across all major architectures, OSs, and form factors. There's also a thriving open source ecosystem around it with like JavaScript libraries and the like. It's flexible for all kinds of different experiences, such as for applications like progressive web apps, but even for books, news, and games. And you can write web apps that are really performant. And what a lot of people don't know is that it actually has a really comprehensive set of APIs. So there's a lot of things you can do on the web, even today. So a short like recap of progressive web apps. Here I'm looking at an old screenshot of my Chromebook, and you see I'm going to this website called Pinterest. You notice that up in the address bar it says install, because this is a progressive web app. It has a service worker, so it works offline, and it has a manifest file, a web app manifest that explains kind of like metadata for this application. If I click on it, I can actually install it. And just by clicking on a button, suddenly I have this application. This that looks really native. Like actually, I couldn't distinguish it from any native app. And as with Service Worker, you can make it work offline. So it's pretty great. But sometimes you might not be able to create that experience you want using the current web technologies. Like maybe there's one API that is really core to your experience that is just not available on the web today. It could be that you're writing something like an app that really requires NFC, but you don't have access to NFC on the web. So that is why a lot of people then go and use like Cordova or like Electron. But it might also be that you have a fear that in the future, you might be lacking one of your APIs. So say that your competitor is writing the same app but using native technology. So your competitor gets access to all the newest APIs as they get released on Android and iOS. But they might not be released on the web for years. So that might be a fear that maybe all your users will move to your competitor because of this. And the web kind of really lacks this like roadmap showing like where it's heading. So all of this can build some kind of distrust in the web platform. So this is just an example. Let's say that next year, let's say like Google is launching the Magic API. So this drives, everyone wants to use this Magic API. Let's say it's something like machine learning on the web. And like everyone just wants this. So but like you embed it on all your product, you embed it on the progressive web app, but you don't know like when this is ever coming to the web. And well, maybe in some sense you could emulate some of it, but maybe it's just not good enough and maybe the performance is not there. So what are your other options? Should you go native then? A lot of people believe that native is always better than the web, but that is actually not the case. Because like I said initially, the web has very little friction, it loads quickly and requires no install. This is also because the web engine itself comes with a lot of features built in. You don't need to distribute that with your apps. It's also like composable. So like with a native app, it's very difficult for you to say if you've installed Twitter and you have installed a news app, then it's really difficult to embed that native app feed inside your like other native app, unless you're embedding web technology. So like also with deep linkability, like that requires, of course, an install at first, and not all apps actually support this. Apart from that, the web is really good at accessibility. So also with native, it's of course like a totally different skill set, but it's not just one skill set, it's a different skill set per platform. So if you want to write like a native app for Android, you cannot just recompile that for iOS. You have to start basically from scratch. And then you cannot, if you want to do like a native Windows app or other kind of native app, it will be the same. Also, a lot of these systems are designed for specific devices, like say Android devices kind of have like a specific form factor. So though today you can run Android apps on Chrome OS, they really don't feel like desktop quality apps. Because like desktop apps are normally something you use with a keyboard and mouse. So a drop-down menu, you really want it to just be like regular desktop like drop-down menu and not like take over the whole screen like it will do on an Android device. So this, of course, can become all quite costly. So there are a few workarounds, like you could use Cordova or Capacitor, but it's not really a best of both worlds thing, because like you lose things like deployability. Of course, you gain friction by requiring an install up front, and they're like also native dependency per platform. So if you want to extend these with a plugin, say to Cordova, well, that plugin will have to be written for each platform. You can, of course, also embed web, but you cannot be embedded yourself. But can we actually fix this? And how can we regain this trust in the web? So this is my overview of what I think is blocking people from adopting web technology. This is what I've heard from talking to developers over the years. Sometimes you have existing code that is written maybe a long time ago, and you don't really have the time to rewrite everything, say in JavaScript. It might be something like Autodesk. They have this application called AutoCAD, and they actually have it running on the web today, but they started like 35 years ago. So the code base is like 35 years old. And it will take considerable amount of time to rewrite all of that in JavaScript. So they went ahead and just used WebAssembly. So we have things today on the web like WebAssembly, SIMD, Threads, and soon WebGPU that will allow you to repurpose existing code and bring that to the web. Sometimes it's bad performance on target devices, especially when you do this like native-like experiences. You really want the behavior to feel native as well. You want scrolling to be super smooth. So there's a lot of good things happening here as well. Of course, we have libraries, like we've had web workers for a long time, not so easy to work with, but we have gotten libraries like Comlink, import from Worker, that makes this much easier. There's also the whole like CSS effort called Houdini, where we're trying to like expose some of the inner working of CSS and allowing people to write libraries that actually, when you need like specific use cases, script, and then like reuse that again and again. So say like you want to do some really fancy animation, you can use CSS Paint or Animation Worklet. We're also getting something called subtree visibility, basically a way to tell that please don't re-render, like render all of my DOM because it's not visible yet, but only do it when I need it to be visible. So all of these things together can result in much better performance for web apps. Another big issue that a lot of people is talking about is that when you do native, it's kind of like easy in the sense that you look at the tutorial says, well, you're writing an Android app, so you're going to use these components, and this is how you do. On the web, it's a different story because it's kind of like, yeah, okay, you're doing the web, but we don't come with a component set. Or like, well, there's some HTML elements, but they don't look that great. And like, you kind of need which framework to choose from. But this is being improved a lot lately. Especially, I think Web Components is doing great. It has taken a long while, but they're finally here. Personally, I use Lit Element and Lit HTML a lot, and I'm really happy with it because super tiny, only a tiny part on top of what's on the web platform, and the results is great. So you're also getting like good toolkits, like Microsoft is releasing Fast for kind of their assets. Google has the Material Web Components based on Material Design, and Ionic has this kind of like more neutral system that works both with iOS kind of design and with Material Design. But like all kinds of companies are creating their own design system using web components and using it across all the different assets. But let's talk about the last thing, what we're actually here to talk about today, capabilities. So we talked about AutoCAD before, so they have this working in the web browser. This is basically a website that can read these AutoCAD files, like the 2D version that accounts for like 90% of all assets out there. They would like to support 3D. We're soon getting WebGPU, so I think that will happen soon, or be happening in the future at least. So you see they have one part of it is kind of the view. This is done by using a canvas and WebGL and WebAssembly, and the rest is basically just Web UI. I believe they're using React at this point. But like a lot of people that use like an application like AutoCAD, they often have big local files. And they might not necessarily want these files to be up in the cloud or to be in a Autodesk cloud system. Maybe they're all keen on using OneDrive by Microsoft or something else, or a local thing. Because like a lot of these people using these applications might even work for the government. I know my dad is using AutoCAD for like drawing roads for the government. And like they have like special requirements that this should only be in a specific cloud system or like on their local hard drives. But accessing local files has been a pain on the web because you normally upload these files somewhere, modify them, and have to download them again. So this would be one of those lacking capabilities. So this is why we're introducing the Project Fugu. So Project Fugu was created by Google and then later joined by Intel and Microsoft. So Fugu, or Hugu, I believe is pronounced, is actually Japanese for the pufferfish or the blowfish. So this is a very cute fish, but it's not always that cute. But in Japan, people actually tend to eat this. So yeah, okay, people eat fish, but this fish actually is poisonous. So if you don't know how to cut it correctly, you might actually end up dying because it have a nerve toxin inside it. So it's kind of like delicious if prepared correctly. And if not, it might actually be deadly. So this is kind of like what we use to describe Project Fugu, because native capabilities are dangerous. As we said, like the web is supposed to be safe. So we need to explain to users what they are doing. And we need to be very careful when exposing these to web applications, because we might break the web. So this is why if we get it done right, it's going to be delicious. But if not, it might be deadly for the web. That's kind of why the name was chosen. So what we're really trying with Project Fugu is that exposing the same capabilities of native platforms to the web platform, but while maintaining user security, privacy, and trust, and other core tenets of the web. So here's a URL where you can read like the original introduction to Project Fugu. And you can also always go to the Chromium bug tracker and search for Project Fugu, and then you'll find out what everyone is working on. But what I really suggest you to do is going to the Fugu API tracker, because that's really, really nice. And it kind of like shows you what we've already been shipping. You can see that with the Fugu logo. So if you look at the WebShare Target API, that is already shipping. If it's green, it means it's currently in an origin trial, and we'll get back to what that is. So it's like a really good overview of what we've already accomplished, as well as what we're working on. So let's talk a bit about the process. One of the problems on the web has been that it traditionally takes a long time to get things standardized, because a standard lasts forever. So if it's in a browser, you need to maintain it, maybe for the next 20, 30 years. So you better get it right when it's landing. So all of this means there's like different browser vendors, and everyone has to discuss and make sure that this is done in the right way. So that basically takes time. So how are we improving this? Well, with Project Fugu, we try to identify need and use cases. And often someone like a partner, like a company that is going to use this feature when it's released. Then we write an explainer. So explainer is this kind of like document that explains you the use cases, why we're doing this, why, if people tried to do this before, why they failed, like some of the solution we've been considering and maybe abandoning because of a lot of reasons. And this is kind of like the starting point. Then we normally put this to the tag to get an early review to make sure that the idea is sound. Then we iterate, start working on the spec, maybe writing some implementation, prototyping. Some early developers will adapt it by turning on a flag. When it's kind of like a bit more stable, we create this origin trial to get like actual developer feedback from actual deployments. And eventually we should end up shipping it. Origin trial is this nice feature that allows a feature to be turned on for a specific site without it actually being shipping in the browser. So it's kind of this interesting thing that it's implemented in the browser, but it's not shipped by default. But you go into this website and you say like, well, for my website, I would like to use this feature. But I understand that this feature might change in the future. It might also never ship. So I need to make sure that my website works without the feature enabled. Because also because this allows me to test it in the wild. Let's say I'm Facebook. So there might be a new like camera API I want to use. So I might turn this on for a certain set of users by using an origin trial. But also if like Facebook's like, nah, we'll just turn it on for everyone. That might be really bad because then later maybe like they don't want to make changes to implementation, and Google or Apple is like kind of like supposed to support it in this like way, this API shape that maybe isn't the perfect one. So even an origin trial has this thing that's an upper limit. So if you get like say like more than, I don't know what the exact amount is, it can change, but let's say it's over 200,000 users, maybe they just turn it off. But what is also important is that as this is this is happening during development, it might be that from one Chrome release to another, there are actually changes. So that is why you have to go and reapply for an origin trial. So the way it works is basically you get a key, like a token. You can add this in your request headers, or you can just add this as a meta tag on your website. Very simple, very great idea. So this is just an overview of how the site looks. So let's now look a bit about like what are we actually working on in Fugu, what have we been working on? So one of the part is hardware connectivity. There was this survey from MDN, and it actually showed that a lot of developers say that they really want hardware connectivity. That is a really important part of what is missing on the web. So actually before Project Fugu, the Chrome team started working on exposing Bluetooth and USB to the web. So this has actually happened, and here's like a very nice example of a web app that actually controls a Lego Batmobile. So it's just like one of the examples of what you can do using these technologies. I have an earlier talk that goes into deep details about USB and Bluetooth on the web. So I encourage you, I want to share these slides with you all after this talk. And I really encourage you to check that out if you have interest and time. So this is already shipping, but people are like, we're not standing still, and people are still working on adding a few additions to make sure that this follows the standards and that people can really use this for their use cases. Another thing very close to shipping is Serial API. So Serial API is actually an old kind of API you probably know from the old like mice and keyboard. But today people usually use Serial on top of existing APIs like USB. So you could say, why don't people just use Web USB if you're going to use like Serial? Well, the thing is that a lot of OSs like Windows and say like Chrome OS, they already understand Serial. So if you connect the Serial device, the OS itself will try to handle it. And thus you don't get access from, say, Web USB because the device is claimed. So this is allowing people to just use Serial directly. And it's also a much simpler API. You don't need to know all these details about USB. So great. And this is very close to shipping in Chrome. Similar is HID. This is, I believe it stands for Human Interface Devices. So this is like a keyboard and a mouse. So if you plug like a keyboard into your OS, the OS will take care of the keyboard, and you don't want to expose that to a specific website. It will work with all apps on your computer. But AIDS-ID is kind of simple, so a lot of people have used this. It works on top of like Bluetooth as well, so Bluetooth and USB normally. So a lot of people have used this for implementing things like a barcode scanner, or like even like gaming controllers. So we also really want to expose this to the web so developers can target these devices as well. So as I said, this is currently in an Origin trial and also very close to shipping. Something we've been working on at Intel is NFC. So NFC is actually a huge collection of different standards, and we need to start somewhere. Some of it is really low level, which means it's really hard to expose in generic way to the web. So what we have decided is to start with the globally supported and simple standard called NDEF, which stands for NFC Data Exchange Format. So today we have an implementation that works great for reading and writing NDEF records to, say, NDEF tags or other devices that can emulate tags. And it's very complete, and you can learn more at web.dev/NFC. Something we've been working on for a while, on and off, and I remember in Japan I showed this to the inventor of the web, Sir Tim Berners-Lee, and even he was excited. So I kind of love this picture. Here's a small demo. I'll see if I can play it back, if I can find my mouse here. And it kind of like shows you a game where like it will show you on the screen. So what it kind of showed you is that it will show you the order on the screen and you have to tap it. So this is like another demo I made. I made this grocery list. So the idea is you have this nice grocery list. You can add things you need to buy. But I thought like, yeah, this is kind of nice. I'm just like showing you how it works. It's a very nice progressive web app using the material components. So I can add like olive oil, and you see it's on my grocery list. But I can also click on this thing called Write to NFC tag instead. So say that I'm often running out of toilet paper. So I could place like a sticker next to where I store my toilet paper. So when I run out of it, I will just like touch that tag instead, and it'll auto add it to my list. So that's exactly what I'm doing here. So I wrote NFC stickers, NFC tags to it, and you see that just by tapping it, it's adding these things automatically. So you could imagine having that like maybe some stickers on your refrigerator. So it's just like an example of what you can do with something like NDEF support. Very simple API. There's an on-reading event, and whenever you get a reading, and there's actually like either like an empty tag or it has like records on it, well, then you can read those out. So here I'm reading some JSON, and I'm even reading out like a binary data, and showing that up as an image on the website. Very simple. This is an Origin trial, and we're very close to shipping this as well. It's basically done. Something else we worked on at Intel is generic sensors. Generic means that we had a lot of sensor support on the web, like geolocation. There was something called device motion and device orientation, but they have all kinds of issues. Like, for instance, like you might not need 60 frames per or like events per second, which will drain your battery. So if you only need 10, why can't you configure it? It's also very high level, so they don't allow you. They introduce like interoperability issue. They don't allow you to do like your own like sensor fusion. And also for sensor fusion, there's like no reading timestamp. So there's all kinds of issue. Also, like the implementation were implemented like differently across browsers. So sometimes you need to know, oh, I'm on iOS, so I need to like modify the values a bit so it works the way I want, because it works differently on, say, Android. So we call it generic sensors because it's kind of like a sensor framework. So you have this sensor base class, and then you have like accelerometers and linear acceleration sensors derived from accelerometers, gyroscope, or orientation sensor, and the like. So I have also written a very detailed presentation about sensors. So if you have any interest in sensors and how they work and how we expose this to the web, I encourage you to check that out as well. Simple example, also because the API is so simple, it's kind of possible to emulate it. So here, just emulated. I made this application use the sensor framework on my phone, and then I emulated it using an IoT device, and I actually used like Web Bluetooth just to like connect to it. I know that you see a USB cable that is just for charging. So as this is only supported on Chromium-based browsers like Edge and Chrome, I have written some polyfills, so you can make this work on iOS as well, and it will make sure that you get the exact same readings. So if you have any interest, check that out. What's also really important on the web is very social. You probably know that. So it's very important about sharing content and receiving content or receiving shares on the web. So we've been working on web share. So web share is basically a simple API that allows you to share some kind of content to other apps, which could be normally like native apps, but of course, like it could also be progressive web apps that have been installed. Very simple API. You just share title, text, URL, and I believe today you can also share files as well, but I haven't actually tried that. Receiving shares requires you to be a progressive web app and have it installed, and you need to extend the web manifest a bit, and of course handle it. So this is actually shipped today, so you can actually do this today. But people at Microsoft is working on improving this support on Windows. Getting back to the whole AutoCAD thing, like reading and writing to files is very important. This is also one of the core reasons why Visual Studio Code is an Electron app, because like you want to deal with your repositories on your local hard drive. So file system access, earlier known as native file system, is the API that allows this. And this is actually shipping today, not on Android though, but on desktop systems. Very nice, very modern API that you can use. Very cool, but we're still working on improving it a bit to cover all the use cases that people have. Apparently I'm missing some slides here, but we have also been working on Media Session that allows you to for instance, get this like share sheet, like this sheet, like if you're playing back a music or a video, you can actually interact with that, or even like using your multimedia keys that you have on your keyboard. At Intel, we've been working on also media streams as well, making sure that we have like excellent camera support, so you can apply your own filters, do pan and tilt and zoom on cameras that support it. So you can actually do like really crazy and cool stuff, like something like this funny hats demo I'm showing here. So here's an example of my coworker Rijo. You see him on the right. He's actually using a camera with supports like zoom and tilt and pan. So this is very common for especially like conference video. So if you want to do something like say Zoom or Hangout or Google Meet today, it could actually support something like this. So maybe like using a machine learning to find out where someone is sitting and talking and zoom in on that person. So this is actually shipping, and we're actually shipping zoom, pan, and tilt as well. We've also been working on future things. A lot of cameras in the future will probably have depth sensing capabilities. So actually a different sensor that can sense how far away things are. So you see here that allows you to actually like really make really nice, like change the background really nicely, instead of using machine learning that often have issues maybe where with your hair and the like. So really powerful. And here's another coworker that actually showed you how precise this is. So he's actually interacting with things in like this scene, just using a depth sensing camera. And I actually find this like super amazing. Like, see, he can actually pick up this box and place on top of another box. So I think like this is like amazing what you can do when you get precise sensors. So it's not so common today, but I expect this would be something that we'll see more and more in the future. So this is not shipping, it's behind a flag. So if you have one of these cameras that support this feature, you can actually play around with it already today. Something else very important on the web, a lot of companies say is very important, is especially if you're in the business of sending packages or like having to maintain a stock, well, then detecting barcodes is pretty nice. But actually, it's kind of like you can detect more than just barcodes. And often there's like special hardware or special like very optimized software on devices that will do this. So this is really important, both because it's fast and also it uses less battery. So shape detection API is the API that does exactly that. It actually has, it's actually standardized to work with barcodes of all kinds, face detections, as well as text detection. But we're currently only shipping it for actually barcodes. Very simple API. Give it an image, and it will detect if there's a barcode there. If you have a video, well, then you need to feed it all the frames. It will also give you back some information about where the barcode is, so you can draw on top of that image to really show like, oh, this is where I detected the barcode. So this has shipped. The barcode support is already shipping today. Another part of Fugu is system integration. So this is like more touching on the progressive web part of it. So we're having batching, like, oh, you have an unread email, unread like instant message. So like you can like kind of do these batches. So some you can even do just like, yeah, there's something unread, or you can even set a number. The system might support showing numbers, like Windows does that, but for instance, Android doesn't, because it's not part of the UI design of Android. So it kind of depends. Sometimes even if you set a number, if it's not supported, well, then it's just going to show a dot instead. But this is also shipped and works on Windows and Android and Chrome OS, I believe. Something else I've worked on is the annoyance of having the screen turn off while you're doing something. Like you're baking a cake, your fingers are all, and you're following this recipe, but now you get this screen, or like you get a dark phone or laptop, and now you need to wash your hands and touch it a bit, and after a few seconds it turns off again. This is actually pretty bad, because it's even pretty bad for battery life, because what you probably haven't thought about is what people do is that they go into settings and turn off sleep, like never turn off the screen, and then they forget to turn it on again. So battery life is always pretty bad because it never sleeps. So the screen is always on. So there's actually already some cases today where the system will not turn off the screen. So if you're playing back a video, so people have done all kinds of crazy workarounds that are even worse for battery, like playing a 1 pixel video on the website just so it doesn't turn off the screen. So we thought, like, why not just like create a API for this called Wake Lock? So actually there's two kind of wake locks. There's a screen and system. System is like, you can turn off the screen, but please don't sleep. But what we're shipping currently is the screen wake lock. So it basically just allows you to keep the screen on without like wasting battery as much, or without people having to go into settings. Very simple API. Request the wake lock, and after a while, then you can release it. There's also all kinds of other things built in. So if you change the tab, unfocus the app, if you turn off the screen yourself, like the wake lock is just going to be released. So this is basically only if you let the device stay there and with the screen on, like then it's going to like stay alive. But of course, we want to like avoid abuses. So this is shipping today. Something else we heard a lot is that a lot of countries really want to like have access to contacts, because it's a lot like based on social. So maybe you want like to send an email to someone, you have your contact in SMS, or you want to bootstrap a social network. But contacts are like kind of like privacy sensitive. So it's really about like making sure that the user knows what is happening at all times. So the way it works is we have this contact picker. It will show you exactly what will be shared with the website. It won't allow you to select all of the contacts. You have to select them individually. And you can even say like, now, well, I don't want to share the phone number. I'm only going to share like email. You are in control. The way it works is that you will tell, first of all, like what you want. Like, do you want name, email, telephone? Maybe you want just one contact, and maybe you want multiple. And then you ask for that. So for instance, if someone like chose me, they'll get some JSON back here, like an array of JSON where they have my email, my name, but not my telephone number. So this is shipping as well, shipping on mobile phones, but we're working on some additions as well. Something else that's really interesting and kind of dangerous is font access. It's kind of dangerous in the sense that you can very easily uniquely identify someone from the fonts that installed on the system. So this is not something you want to expose to all websites on the web. It's really only for those apps that really need it. And like those apps do exist, especially like something like Figma, where you're trying to design like app UI. Like it's really important that you get the right fonts. Same thing like for say like a presentation. Like I might have a special Intel font on my laptop that's not accessible online. It's not accessible in Google Slides, but maybe I can access that if I allow it. So this is also something we're working on. Something I've been working on, or I am working on personally at this point, is support for an upcoming set of devices. Some devices are called with foldable screens, and some devices that emulate that using two screens. So they kind of have one virtual screen. So this is kind of a new set of emerging devices that are ultra portable, flexible, and allow for new kind of multitasking scenarios. So a foldable device is a device where the screen is actually foldable physically. It might not be as good with like touch events exactly where the fold is. And other devices like a dual screen is one that's based on two screens. So we've been working on different APIs for this. Something like better support for virtual keyboard, because it might just be on one of the screens. Support for knowing the fold or the posture the device is in. And ways that you can span an app across these screens and avoid having like a dialogue in the middle. So for instance, if you look at this example, my coworker wrote, Alexis, you see it's very nice. If I put it in the screen in the middle, this is on a dual screen device, you see like the image kind of get cut. It's not the nice experience you want, especially for these like zoomed in images. This doesn't look that nice. So spanning is the solution to that. So this is like how it's supposed to work. So if you use this support, which is supported from JavaScript and CSS, you can change the experience to become something like this. I have another example of the video, another video here, because we actually wrote this small like polyfill for this and a small widget, like a small like web component you can drop into your web page if you want to play around with this. So you see now I'm emulating this feature. And it even have some pre-configured devices, like known devices that actually are like foldable and dual screen devices. So really nice example that really allows people to use this already today. Here's another of a Battleship game. So you can really see this, so that you can create all kinds of new experiences using these devices. Very exciting. So some of this is shipping in Edge behind the flag today, and we're working on integrating all of these kind of experiences, even like support for multi-screen devices. So we have like one coherent solution. Microsoft has been working on what they call customization of the title bar. So you see a lot of like native app today. They like you see like Visual Studio Code. This is an Electron app, but so it's semi-native. They allow like the title bar to actually have all the menu items. And you see Teams that have like this search thing in the title bar. The same with Spotify. So we would like Progressive Web App to have the same ability. But if you give Progressive Web full control of the title bar, they can emulate like a browser and they can do like phishing attempts. So it's a really difficult. So we have to find a solution where that is not possible. Also really very, very difficult to do, because we really don't want people to get phished. So if you look before the Project Fugu, you had all these kind of APIs. Like I said, the web already had all kinds of APIs available. But with Fugu, you're already getting all these new kinds of APIs. So really filling the gaps. There's still a few gaps, but we're still working on it. And the web is going to be pretty awesome. If you have something that you believe is really missing on the web, so that for you to actually adopt web technology, please go and file a request. So you can go to bit.ly/new Fugu request and actually file an issue in the Chromium bug tracker. So some of the resources, go to the API tracker, make sure to have an overview of what's going on, get that roadmap of what is coming to the web, also to see if that thing that you need is already being worked on or not. You can also go to the capabilities landing page to learn a bit more info about Project Fugu, but really join the effort. Like there, the Fugu Sync meeting, like reach out to me on Twitter if you're interested. In the W3C, if you're a member of W3C, like some of this work is going on in CSS working group, like things like especially the dual screen thing. It's also happening in the second screen and device and sensors working group. So like pitch in. And with that, I want to say thank you for listening, and I'll stay on, and I'm ready for like a lot of nice and good questions. But also feel free to follow me on Twitter and reach out to me on Twitter. And with that said, yeah, I hope you enjoyed this talk. And now I can finally get some coffee.
Okay, so thank you for that really wonderful talk. We do have some questions here from our registrants and our
Okay,
viewers.
nice.
So yeah, let's have this first one. So, were you able to try eat Fugu, and how was the experience like if you were able to?
Yeah, I have actually tried eating fugu, I think like 3 times. So the first time it was like fried, so it was just good fish. I guess like maybe the frying like hit the taste a bit. Then later on, I actually ate like the raw pieces of fugu. It was pretty okay. Like people said, it's like extraordinarily great experience. Like, well, it was good, but I had expected something maybe better. And the last time it was a very fancy restaurant where actually apparently like, what is this thing there? Well, that's a bit of fugu brain as well. So, okay, yeah. It was okay. It was good. But maybe not that out of this world experience that I had like expected.